how to use a computer to generate the normal curve, and how can use a computer to get probabilities. Today, I want to start showing you how we can use the normal tables, and you are able to figure out the probabilities. So let's look at this. Let me share my screen. Okay, so we have a question here about the normal distribution, and the question says, okay, go ahead and open it. The question says that, okay, I have it now. It is about using the standard normal tables, okay? Use the standard normal tables to find the probability of Z more than 1.825. So what we do is, first of all, to understand the inequality they are using here. So I want to have a normal curve, okay? And on this axis, I want to have Z values. So the normal curve has the mean 0, okay? So on the positive side of 0, let's say 1.825 is right there. Okay, so let's draw the normal curve. So we are looking for Z values that are more than 1.825. So this is what we do. We look for values starting from 1.825 going to the right, okay? So this is the probability that Z is more than 1.825. That's the shaded area, okay? But remember the normal curve. The normal curve is symmetric about the mean. The standard normal is also symmetric about the mean, which is equal to 0. So how do you find the required probability? There are two ways of going about this. Actually, there are two tables we can use here, okay? The first table reads from the negative side up to a particular value of Z, okay? So it depends on the type of table you are using, because we use different tables, okay? So, but how do we interpret this? Let me take this table. I have this table right here, okay? When you look at this table, the shaded part there is reading from negative infinity going up to a particular Z value. So it reads the whole of that area. Okay. Now, how do we make use of this? And then we are able to, figure out what we have here. We want the probability that Z is more than 1.825. So this probability will be equal to 1, because the total area under the curve is 1, minus the probability that Z is less than 1.825. This will be the case if I'm using the table right here, which reads from negative infinity up to a particular value of Z. So this table reads probabilities for Z less than a particular value, okay? And what's the probability for 1.825? The first place of decimal is obtained from the first column on the left, okay? This column right here gives me the first place of decimal. So I look for 1.8, okay? 1.8 is right here. This is the value I'm looking for, 1.8. But the question is 1.825. So where do we get the second place of decimal? This is 1.80, this 1.81. You can see the numbers here. This 1.80, 1.81, 1.82, 1.83, 1.84. So 1.81, 1.81, 1.82. 1.82 is 0.9656. Okay. So I have the probability that Z is less than 1.82, okay, is 0.9656. But I have another place of decimal, because the question is 1.825. So 1.825, I have to move straight across up to column number 5, in the column of addition, I look for column number 5. This is 1, 2, 3, 4, 5. So the value I have here in the 5th column is 4. I'll get that 4 and add it right here. Okay, so you add on the last place of decimal. So this is a 0, this is a 6 now, and this is a 6 and 9, 0. Okay, so the probability that Z is less than 1.825, sorry about that, 1.825 here is 0.9660. So here you have 1 minus 0.9660. Okay, so you go ahead and subtract it. What do you get when you have 1 minus 0.960? It's going to be, okay, it is a 0, then I have, that will be a 10, so a 4, that's a 9, which is a 3, and that is a 0, then I have 0.0, okay, 340. That's the probability that Z is less than is more than 1.82. So it's just a small probability, which is 0. Okay, it is 0.0340. So that's how we use this type of normal table. But there is another type of the normal table, which is the most common type. Let me go ahead and add here a page. Okay, let me use black this time. And then I have white. So I can, okay, it is okay. I have lots of blackboards here. I have a blackboard, I have a green, whatever color I want to use. So this is the normal curve, okay? I have that curve. Let me, okay, I have that kind of curve. And these are Z values on the x-axis. So I know the standard normal is symmetric about 0, okay? That's the 0 line. I'm looking for 1.825 on this other side, okay? 1.825. Then I want the probability that Z is more than, so Z values that are more than 1.825. So this is the probability that Z is more than 1.825, okay? So I want to use a second set of table, okay? I have two tables here. The first table is reading from negative infinity up to this point. But I have another table that reads from 0, okay? There is a table that reads from 0 up to this point directly here, okay? So what do I do if I have such a table? This is what I'm gonna do. I know that the whole of this side, okay? The whole, let me draw some things, okay? If this is 0, then this probability that Z is more than 0 is 0.5. Okay, so the whole side, the whole right hand side is 0.5. So how do I use that? Since I need this area here, okay, I know that if I color this other area, let me color it blue. I know blue may not appear, but if I color it green, okay, so the area in green, which is area 1, and then this area 2, sum up to 0.5. Because 1/2 of the normal curve is 0.5. So this is what you do, find that probability using this other table that reads from 0 up to a particular value of Z. So this is what you do. The probability that Z is more than 1.825 plus the probability, okay, that 0 is less than Z is less than 1.825, that probability is equal to 0.5. It makes 1/2. Okay, so I need to read area 2. This is area 2, and this is area 1. I need to read area 2, which is the probability that Z is more than. So the probability that Z is more than 1.825, okay, it will be 0.5 minus the probability of 0 less Z less 1.825. So the task I have to read this probability. This is 0.5 minus. So how do we read probability of 0 less Z less 1.825? We go to this other table, okay? There is this other table right here. It reads between 0 and a particular value on the positive side. So I first figure out where 1.8 is. So this 1.8, 1.825, let me use red so you can see. 1.8 is right here, okay? 1.80, 1.81, 1.82. 1.82 is 0.4656, okay? But we have to go up to, you know, we need the third place of decimal because this is the first place of decimal, this is the second place of decimal right here, okay? And then the third place of decimal will come from the column of addition. So we move straight across and go to, this is 1, 2, 3, 4, 5. So we add on a 4, okay? We get a 4 and add on what we have here, okay? So we have 4656, okay? Let me move to the next page. 4656. I have 4. My color is so bad. 4656, then add on a 4, and then this would be a 0, this would be a 6, okay? This would be a 6, this would be a 4, okay? So it is always the 0 point, but you know, because the person printing this book wants to conserve space, you will not see a point on these other values, only see a point on the first place of decimal, the second place of decimal, which is 1 point whatever 0, okay? That there will be a decimal point appearing here, but you will not be able to see the decimal point on these other values. So all of them have decimal point, that's what you have to know. Okay, so we have got 0.4660, and then we need to get this and subtract from 0.5. So it is 0.5 minus 0.4, oh, that's a bad color, minus 0.4660. So you do the subtraction, and I'm quite sure you'll end up with exactly the same thing, okay? So that is 0. And you can use the calculator, there's no problem if you don't want to, but this is just some kind of mental work, okay? 0.5 minus 0.4660 is 0 point, okay? We have 0 point. This is a 0, then you have a 9, 10, so that is a 4, and then you have here 9, which is a 3, okay? And then you have, okay, so it's 0.030, which is exactly the same probability we got in the first case, okay? Exactly the same probability, 340. That's exactly the same. So it depends on which table you are using. So starting from this moment on, I will stick to the table that reads from 0 up to a particular value on the positive side. I will kind of abandon this first table. Though this is the table I like using most, okay? I prefer using this table more than the other table because this reads from negative infinity up to. I will go on and use this other table that reads from 0, okay? It reads from 0. This table is reading probabilities from 0, okay? It's not indicated 0, up to a particular value Z on the positive side. So it gives probabilities that are less than 0.5. Okay, so that is it. You have to know how to use these tables. You must know how to play around with the table to be able to read probabilities. Okay.